Hello and welcome to Groundhog Graphics Retro. My name is Martin, and today I want to discuss the RAM expansion unit for the Commodore 64. Or is it for the 128? Well, actually, it's for both. They have a Commodore 1750, a 1700, and a 1764 that will work on both machines. And I don't know all the details yet, so what I want to do is hit the books and see what we can find out. Let's get to it.
So now I've written a program, and this program is not complete, but the program I've written enough for this part of the video. I am probably going to end up making this video into separate parts, and so I'm going to go ahead and run it. It's called REU RAM Expansion Unit Trainer TR, just like I did with the time of day clock. And that's it. Let's go ahead and run it. Now, mind you, I ran this program from within the PowerC shell. Even though this video is not about PowerC, like I said before, this is the environment I prefer to use rather than BASIC. I haven't programmed in BASIC for a long time, and I don't know if I remember how to program in BASIC that well anymore. So what we have here is a list of different memory locations. All these memory locations we use to control the RAM expansion unit. And some of these memory locations actually are more than one. If you look at number 3, the C64 C64 address. That address is at DF02 and DF03. Now I indicate all the addresses that I've combined together to form one labeled register on the screen. All those addresses have a +1. So that means those are 16-bit values. And when they are 16-bit values, to the right you will see that there is not a binary representation, but there is the decimal representation. We don't really need a binary representation on the 16-bit values. So let me give you a quick overview of the registers. Status register is a read-only register at the very top, and that will let us know, well, probably several things, but right now it will let us know when we actually transfer a block successfully, a block of memory, to a RAM expansion unit or from the RAM expansion unit. It will show a 1, I believe, in the bit number 6, and if I'm wrong, I'll correct it when I'm editing. And then we also have number 2 is the command channel, and that is what allows us to execute a transfer with the RAM expansion unit. So we use the command channel to finalize our transfer. Then we have the C64 address, which is also known as the host address in the 1750 manual. And in that manual, it's the host address, so that is where your transfer inside of the Commodore 64's RAM area, whatever within that 64K area, that is the address it will begin transferring. Then we go to the REU address, and that is also where the transfer will begin inside the REU. And the reason why we have these addresses and why it transfers in between the RAM expansion unit and the Commodore 64 is because you cannot actually directly access this memory that is on your RAM expansion unit. Your RAM expansion unit, you might have 512K or 128K or whatever it is, but you can't access it without swapping it in and out of the actual Commodore 64's 64K memory area. You have to bring it in or swap it out. You can't go and write directly to the RAM expansion unit, at whatever, even at any memory location in it is not accessible except through these registers. So, REU address sets the memory location for the REU. REU bank, each bank in the RAM expansion unit is 64K. And if you notice on this right here at number 5, REU bank, is the right 3 least significant digits of the binary number are all zeros. Those digits are the only digits used on the 512K model. The digits that are all 1 are not used. They can't even be changed. So on the right now is 000, it is actually pointing to the bank 0. Now next we have exfer length, which is transfer length. This says how many bytes do I want to transfer from the Commodore, or how many bytes do I want to transfer from the RAM expansion unit. Currently, it says it wants to transfer 65,535. This RAM expansion unit can actually transfer 65,536 bytes in a single shot. And how to transfer the 65,536 bytes is to put a 0 in that slot. So 0 transfers the largest size that you can. And you can put a size in there, 1,000 or whatever you want to do. Then we have the interrupt mask. The interrupt mask I have not used that much at this point. You can obviously tell it to have interrupts at certain points or turn off certain interrupts. Right now that is not actually significant in using the RAM expansion unit. So next we have address control, and that one does some neat little tricks that are kind of cool that at first I really didn't understand, but when I started playing around with it I did get a grasp of it, and it actually has some pretty neat advantages to it. We'll get into that later. So now to work the RAM expansion unit, what we have to do is some preparation. We have to set it up to do a transfer, and then the final thing we do is write to the command register DF01 to do the transfer. So first, let's go ahead and let's record the screen that we're currently looking at. And we'll do that by poking, poke, let's see here, DF02, and we will poke that with 1024. And if you guys notice, the poke statement in the last video, I told you I was going to update it to accept hex values, and it does. You can now use hex values for the memory address. You can use hex values for the value that you want to poke into memory, and you can actually interchange them, and that's what I'm doing in this example right here. So I'm going to poke in screen memory into DF02. Also, the nice thing is with the poke statement is if you poke a value that is over 255, it will poke integers with little endian. It'll poke them little endian into memory for you. So that's a lot better than basic, isn't it? So anyway, let me go ahead and let's put that in there. DF02. Now our REU address is at 0, so that's fine. Bank is at 0, so that's fine. Transfer length, let's go ahead and input 1,000 bytes in there. So poke transfer length DF07, and we will put in 1,000. So that's the entire screen memory area. Interrupt mask we don't need to mess with, and we don't need to mess with the address control register. Those are fine. So now we are going to be able to execute this and transfer the screen into the RAM expansion unit. So we're going to poke, and we're going to go with the command channel DF01, and I'm going to put in B0. Now I'm going to show you guys just in a second why I put B0 in to transfer. Now I'm going to go ahead and hit enter, and that's done, and now it's transferred in the REU. Okay, so now let's look at the book. So here's the book, and The command register right here, which is DF01, this was the register that we used to actually commit to the transfer, to execute it. And bit 7, by setting bit 7, we will execute the transfer. However, there are some other bits here we have to pay attention to when we do this. There's also bit 5, which is auto load. I'm using auto load when I did the poke statement earlier when I put in the B0. Auto load will reload our setup. So our C128 base address, or in our case the C64 base address, the expansion RAM address, the expansion RAM bank, and the transfer length will all be reset automatically to the settings before the write or read. It'll automatically be reset by auto load. If we don't select that option, then what happens is the base address for the Commodore and for the RAM expansion unit will both advance by the transfer length. And if we were to cross over a 64K boundary, the expansion RAM bank would also increment, and it would reflect the next bank of memory. So without auto load, all this stuff continues to advance, and which is very useful, just depending on what you're trying to do. But in our example that we're working with right now, I want all this to just stay exactly the same, because I'm going to swap between the RAM expansion unit and the text memory. So that's why I'm using auto load. And then we have disable FF00 with a 1, so that's important. I haven't experimented with this yet. From what I've read, my interpretation is that it has something to do with turning off I/O space and being able to copy the RAM underneath I/O space. And I guess without this option, you actually can't copy under the I/O space, because by the time you turn off the I/O space, you may not have access to the RAM expansion unit. But this is just my theory or my interpretation so far of what I've read. I do plan on, of course, trying it and proving what this does. So for right now, that's what I think it does. Now, down here we have our transfer type, obviously important. 0 transfers the C128 or C64 RAM to the RAM module. Then we can transfer from the RAM module to the C64. And with this value here, we can swap memory at the exact same time. So we could swap the screen with the RAM expansion unit and then swap whatever was in the RAM expansion unit right back to the screen, kind of like page flipping. And that works actually half the speed of any of the other transfers, because it has to do 2 transfers, so that makes sense. And then we have a verify, and I haven't done a verify yet, so that actually I'm sure will also come in very handy. So for now we have the interrupt. Well, then why I have this interrupt mask register? You can see we have interrupt enable, which interrupts are enabled. That's into block mask. So I don't know what this interrupts enabled. Maybe it just means for all these interrupts. That's probably what it is. So if you can turn all the interrupts off or on with this bit 7 is my guess. But once again, I haven't messed with this yet. And into block mask, that's going to turn on and off the when we complete a transfer from the REU. That is going to probably determine if the interrupt occurs up here in our status register with the end of block. So maybe if we turn that off, maybe end of block doesn't show up here. I don't know. Haven't tried it yet, but that's what it is right here, and we will eventually get to it. And the address control register, its default, like it says right here, is set to increment both the RAM expansion unit address and the Commodore 64 address after a transfer is done. But we can also change it, so we can fix the expansion address to like 1 byte inside that address, and it won't change. So you could effectively transfer if you pointed to byte 0 in the RAM expansion unit, and byte 0 had a 0 in it, you could transfer the that 0 to the entire 64K of RAM in your Commodore 64, clearing everything and of course crashing your system. And you can also fix the C64 C128 address, and you could transfer everything with it. Well, you could transfer an entire 64K block of memory from the RAM expansion unit to that single byte in your C64, and that could prove to be very handy if you wanted to copy the contents of RAM or the RAM expansion unit into onto a floppy disk or something. And then you can fix both addresses, and I'm at this point not sure what advantage that would have, but it's available. So maybe later on I will figure that out too. So let's go ahead and get back to transferring and see what's happening with our emulator. Okay, so now we're back to the emulator, and now you see that I've poked in DF02 with 1024, the base start of the text area that we are looking at right now, and DF07, which is our transfer length, that's set for 1000 bytes, which is the size of the entire screen right here in our text mode. And then I did a transfer with B0 to the RAM expansion unit, because you see the second digit is a 0, and so that did a transfer to the REU. And now let's go ahead and clear this, and let's take a look at our registers before we do it anymore. CLS. Alright, so REU, TR, and let's see if our values are in there. So, yes, they are. Number 3, 664 address, 1024 is right. Transfer length is 1000, that's right. Address controller, that's not fixed, so that's fine. Everything's looking good. The command register, oh, and you can see up here in the status register that bit 6 is set, which shows that we had a successful transfer. Now, if I read it again, you'll see that it will, and there it is, so it's cleared. So it's, you read it one time, and then after that it clears itself automatically. So, all right, so now we know we have that. All I need to do is do another transfer from the RAM expansion unit back to our screen area and see if it works. So let's clear the screen, and we have to poke in DF01. So poke DF01, comma B1, and this should transfer the screen. Well, it should transfer from the RAM expansion unit right back to our screen. Ha! And it did. And there is exactly what we saved to the RAM expansion unit. So it worked. Cool. That's so cool. Alright, so now we've done a transfer to the RAM expansion unit from the RAM expansion unit. And so I think now what we should do is go back and do a swap. And let's see how a swap works. Okay, so now if we want to do a swap, let's go ahead and we'll have something to swap with. Let's do a directory listing. Okay, so now we have a directory listed. So now we got something to swap with, so we can tell what's going on. Poke DF01, our command register, and we're going to do B, and this time for a swap we're going to do 2. So B2, we'll do the swap. Yeah, that should work. Okay, so you guys ready? I'm going to hit enter and see what happens. Cool, there it is. It's swapped out what was already in the RAM expansion unit. It put it back on the screen. Now, if we do a swap again, I imagine we should see our directory listing. So poke DF01, comma B2. Ha! That's That's cool. So now there's our directory listed. So now we're just doing swaps between the RAM expansion unit and the C64 memory. So that's cool. So now, what are we going to do? I don't know. Let's go REUTR and see what that brings up for us. Now, I've been doing the transfers with autoload. Let's do a transfer with autoload turned off so you guys can see, how these registers are then changed and affected. So let's go ahead and take these settings that we've already got, because that's the easiest thing we can do, and go DF01, and this time instead of B we need to do, I think it's 9, right? Yeah, B9. And so that way what we're doing is we're setting the execute bit, and we're also setting the bit for the FF00 memory trigger thing, the stuff that for the IO space. We have to set it so we can turn it off. So, but for auto load, that's not being set. So this time everything should advance and do what it does in its default state. So I'm going to go do a 9 and a 0 so we can write to the RAM expansion unit, and let's see what happens. Okay, so now I'm going to run REUTR again, and you guys are going to see that. Look at the C64 address. You see it's 1024, and REU address is at 0, and the transfer length is 1000. Those three registers are going to change. So watch this. Bingo, look at that. C64 address is now 2024, which is 1000 bytes ahead of what it was. The REU address is at now 1000 because it was 0, and our transfer length is now 1. So that is what happens when you don't use autoload. And then we know you can continue transferring or whatever you want to do from there, but now you see what autoload does for you. So I appreciate you guys for watching. Thank you so much. I really hope you guys enjoy the videos. I will catch you next time. Thanks. Bye.